So, horizontal asymptotes. Horizontal asymptotes are things that we've seen before and we haven't needed limits to find it, and that's generally because it was telling us about something very specific. So, horizontal asymptote. The line y equals L is a horizontal asymptote of the graph of a function f if x approaches negative infinity. So, the limit as x approaches negative infinity of f of x is equal to L, and we can do the same thing for positive infinity, and they just changed their value to m instead because they don't have to be the exact same. Horizontal asymptotes tell us about the end behavior of a function. So end behavior is kind of like the arrows on the ends of our graph. It's talking about what's happening, where is it going. So when finding a horizontal asymptote of a rational function, we needed to look at the numerator and denominator and see how each of them are growing in relationship to each other. So one of the things that we need to think about is called magnitude of functions. So we are looking at positive x values, specifically really large ones. So we're talking about as we go towards infinity, what is going on. So we have three different functions that we normally look at: logs or logarithms, polynomials, and exponentials. So one of the things that we need to kind of think about is when we think about a log, logs and exponentials are inverses of each other. So one of them has to be bigger than the other. And if we think about what an exponential does, is it increases rapidly without bounds. So exponentials are going to be our biggest magnitude here. So if something has an exponential, more likely than not, that exponential is going to grow faster than anything else that we have going on there. And the bigger the base number, the faster that it's growing. So we can kind of look at that as well. After that, we can kind of look at polynomials. Polynomials are something to a power. So if that power is bigger, then our function grows faster. Lastly, we have logarithms. If our base is higher, then we're going to be growing at a faster rate, but logarithms grow the slowest. So if we think about what that look like is if we see something like log base 2 of x and compare it to x squared and 2 to the x power. 2 to the x is the biggest, then x squared, then log base 2. So this is only true for big positive values of x. If we're talking about negatives, then it's going to go in the opposite order. Logarithms are going to go way faster, but at the same time, we need to remind ourselves that logarithms, we can't put a negative number into a logarithm by itself, and 0 can't even really go in there either. So we need to be a little bit careful with logarithms. So we're going to be talking about some acronyms that you guys may or may not have heard before. These are some of my all-time favorites. So if we have a function that is growing faster on top than bottom, so our function f of x goes to positive infinity or negative infinity. So when we are talking about a function growing faster on top than bottom, what we're saying is that we might have something like x cubed over x to the first. We call this botno. Botno means bigger on top, no horizontal asymptote. When we talk about it as a limit, that just means that our limit as x approaches infinity or negative infinity of our function, it's going to be going towards positive or negative infinity. So it's going towards that infinite thing. It's in behavior that grows without bound. On the other hand, if the function on bottom is growing faster than the function on top, then f of x is going to go to 0. So this kind of goes back to the thing at the very beginning, these right here. If we have something over infinity, it's going to be 0, and if we have something where infinity is on top, we're going to be looking at that positive or negative. Okay, we call this one Bobo, which stands for bigger on bottom. And our y value equals 0, or we say goes to 0. So this means that the limit as x approaches infinity of our function, or negative infinity, it's going to equal 0. When we are looking at positive versus negative infinity, we just need to think about the sign, and then everything else will kind of fall into place. Okay, and the last one, the top and bottom functions are growing at the same rate, so our function f of x goes to the ratio of the leading coefficients. We call this one eats DC. Which stands for exponents are the same, divide coefficients. Specifically, we want to talk about dividing the leading coefficients. So we get something like the limit as x approaches infinity of f of x is going to equal some number divided by another one. So we are going to be looking at what this would look like in different situations.